This problem is one of the classic problems in determining the measurement of angles in any polygon. In our module, we have presented with polygons in terms of quadrilateral and pentagon, but I just decided to use here a triangle for this practice exercise. Here, we are to determine the measurement of x that could actually satisfy the triangle here. And then with the use of that, we could determine the measurement of angle ABC and angle ACB. And then it would actually be those measurements could affect the solutions for the remaining three items here. So things first, we need to solve here the value for x, which could actually help us in determining the rest. So to solve for the value of x, we are going to make sure that this is really a triangle. And by the use of that assumption, we could actually use here the formula for the sum of the interior angles of a triangle, or any polygon rather, as s minus 2 times 180 degrees. And since n is 3, as it is a triangle, a polygon with three sides, that's 1 times 180. We know that the sum of the interior angles, the sum of 65 degrees, x plus 20 degrees, and 2x plus 14 degrees, their sum is 180 degrees. Aside from this process, we actually have a theorem in our module which is actually the triangle angle sum theorem. This theorem states that the sum of the interior angles of a triangle is 180 degrees. So either way, they both mean the same thing, which is the sum of these three angles should be 180 degrees. So to solve for x, we just simply need to use that. The sum of 65 degrees, and we have x plus 23 degrees plus 2x plus 14 degrees, and that should be equal to 180 degrees. Right? This is made possible again by the triangle angle sum theorem, or this solution earlier, which tells us both of them tell us that the sum of these three angles should be 180 degrees. It's not all the time 180 degrees. I just like to make just clarifications. It's not all the time that it's 180 degrees. We are used here 180 degrees because our polygon here is a triangle. Now, if our polygon is a quadrilateral, if it's a pentagon, a hexagon, and the other types of polygons, we need to solve first the sum of the interior angles, and then use that sum to solve for the sum of the interior angles in the given. So for this item, let's continue. X plus 2x, that is actually 3x. 65 plus 23, that's 88, plus 14 is 102. 102 degrees is equal to 180 degrees. Then subtract 102 degrees both sides. Right? You will have here 3x is equal to 180 minus 102 is 78 degrees. And finally, divide 3 both sides. The value for x is 78 divided by 3, or 78 degrees divided by 3 is 26 degrees. Let me check that. Times 3, 18 times 3, 6 plus 1, 78. That's correct. So this is the value for x. Definitely, we are going to check it later. But just need to use it first for number 2 and number 3. And before proceeding to items 4, 5, and 6, we will do the checking. Okay? Why do I say we need to answer number 2 and number 3 first? Is that when we try to check later, we are still going to use here angle ABC rather, and angle BCA or ACB. So let's answer number 2 first using this value. The measurement of angle ABC is equal to, okay, this equal to the quantity ABC is here, x plus 23 degrees. So if x is 26 degrees plus 23 degrees, the measurement of angle ABC must be 49 degrees. As for ACB, it stands for 2x plus 14 degrees. Substitute the value for x. 2 times 26 degrees plus 14 degrees. 2 times 26 is 52 plus 14 degrees. Let me move this a little bit lower here. So the answer for number 3, the measurement of angle ACB is 52 plus 14 degrees. That's 66 degrees, right? So these are now the values for, or the answer for item number 2 and number 3. Before we proceed to item number 4, 5, and 6, we need to make sure that our answer in number 1 and number 2 and number 3 with that value are all correct. And how do we determine that? Let's go back to the sum of the interior angles here. As we all know, it's a triangle and it's given that all the sum of the interior angles of a triangle is 180 degrees. So let's add them up. Not x, let's add this up. 65, right? 65 degrees. It's already checking. Plus the measurement of angle ABC is x plus 23, but it is actually in number 2, 49 degrees, as we use the value for x, which is 26 degrees. And then plus the measurement of angle ACB or angle BCA is 2x plus 14 degrees or 66 degrees. And this 3 should sum up, question mark, to 180 degrees. If they will sum up to 180 degrees, that would mean number 1, 2, and 3 are already correct. But if they will not, so probably number 1 is incorrect. That will actually automatically mean number 2 and number 3 are incorrect, and we need to repeat the processes. But let's continue here. 65 plus 1 plus 49 rather is 114. 6 plus 9 plus 5 is 14. 6 plus 4 is 100. So 114 degrees plus 66 degrees is 180 degrees. Now that we are sure that they are equal and it satisfies the claim that this is really a triangle, numbers 1, 2, and 3 are now correct. Now we can proceed to number 4, 5, and 6. But in number 4 and 5 and 6, we will not be using anymore this relationship here that the sum of the interior angles is 180 degrees. Rather, we will just be using the measurement of each of the interior angle. Here we have 65, x plus 23, which is 49 degrees, and 2x minus plus 14 rather, which is 66 degrees. Why? Because angles P, K, and N for numbers 4, 5, and 6 respectively are actually exterior angles of this polygon. They are exterior angles because they are angles formed by extending one side and it's paired with the other side. And the measurement of the exterior angle is supplementary to the adjacent interior angles. Okay, it is supplementary because they are forming a linear pair. Linear pair angles forming a linear pair are supplementary, so they must sum up to 180 degrees. So that would mean if we are going to sum up the measurement of angle P plus 65 degrees, they must sum up to 180 degrees. For angle K here, if we are going to sum it up to the measurement of x plus 22 degrees, which is again given here as 49 degrees, they must sum up to 180 degrees. And finally, for angle N, and this angle here, 2x plus 14, which is given to be 66 earlier, or computed to be 66 degrees, when we add them up, the measurement of angle N plus 66 degrees, they must sum up to 180 degrees. Okay, so let's try to check whether they're actually supplementary or not. So we have here for number 4, minus 65 degrees on both sides. So you have the measurement of angle P is equal to 180 minus 65 degrees is 115 degrees. This is the answer for number 4. For number 5, we will subtract 49 degrees both sides. So the measurement of angle K is equal to 180 minus 49, which is 131 degrees. And finally, for number 6, minus 66 degrees, both sides. So the measurement of angle N is equal to 180 degrees minus 66 is 114 degrees. Right. How do we know if the answers for number 4, 5, and 6 are all correct? Number 1, again, let's go back to the figure, and they should be supplementary. 115 plus 65, 180 degrees, that's correct. Next here, angle K is 131 degrees, plus this angle, which measures 49 degrees, is also 180 degrees. Okay, mathematically. And just use mental math here. And then the measurement of angle N is 114 degrees plus this angle, which measures 66, will also yield 180 degrees. That's one way to check. The other way of checking whether these three answers are correct is given to us by the exterior angle theorem. Exterior angle sum, sorry. Exterior angle sum theorem. Okay? Exterior angle sum theorem tells us that in a polygon, if we are going to come up with one exterior angle per interior angle, so in this case, angle P, angle K, and angle N, if we are going to sum these three up, they must sum up to 360 degrees, and that is constant. That's on the theorem that if we have exterior angles per interior angle here, they must sum up to 360 degrees. Let's find out if they will really sum up to 360 degrees under the exterior angle sum theorem. So we have here 115 degrees plus 131 degrees plus 114 degrees. They must sum up to 360 degrees. Then 115 plus 131 is 146 plus 114, 150, 246, 300. We have here 360 degrees is equal to 360 degrees. So per exterior angle sum theorem, we have satisfied that these three are all correct, and they are actually the exterior angles in our given problem. So this practice exercise include the determination of the triangle angle sum theorem, or using the formula for the sum of the interior angles of any polygon. Okay, it's not all the time it's 180 because it might be quadrilateral or pentagon later on, but we'll just do the same processes. And in for items 4, 5, and 6, because all of these three are exterior angles partnered with each of the interior angle using the exterior angle sum theorem, All of these measurements must sum up to 360 degrees, and they did. So this is how we answer this practice exercise. Please continue on answering this one in your own, and you may use this as part of your review. See you soon.